Welcome back to IT Project Management. In this module, we will look at the connection between scope, schedule, and budget management in an agile environment. As we have seen earlier in this course, agile project management follows a different philosophy when it comes to logging and building the production lifecycle that is part of an overall project management lifecycle. Here is what you will learn by the end of this module. You will be able to describe different types of agile project structures. You will be able to manage requirements and feedback loops in an agile environment. You will be able to write user stories and administer a product backlog and estimate user stories with story points. You will also be able to calculate velocity and productivity metrics and differentiate when agile project structures are more or less useful than waterfall structures and when hybrid models are warranted. As a reminder, we realized in the last module that project schedule and project budget are intricately connected. For example, less expensive resources can take more time to get something done, while more senior resources who have higher rates per hour may take a shorter time to get the same job done. This is why, especially in IT, schedule is most often developed in dependency with cost, always assuming that an organization values both the same. However, some organizations can value schedule more, so that getting a new product out fast or being the first to market, no matter what the cost, becomes the constraint. Some other organizations don't have much money, so work can take as long as needed, as long as a budget threshold is not crossed. So what's the big difference between an agile project environment and a waterfall environment? Well, in a waterfall environment, we have to be absolutely sure about what we're building. That's why we have, in this course, spent quite a bit of time on scope definition and scope documentation, and we know that in a traditional environment, scope does not change until you collect all the information and file a change request with the project sponsor. This project sponsor then has to approve the change request to adjust schedule and budget to expand or contract as scope gets bigger or smaller. That's what we call the predictive lifecycle model, or the waterfall lifecycle. However, what happens if our client does not exactly know what they need, or if we're building something completely new that is in some ways explorative? Then we have a higher percentage of uncertainty in our project. That is where a more change-driven, adaptive model might be more appropriate to use. This change-driven, adaptive model is sometimes called the Agile model, sometimes it's called the iterative model, or in some cases just Scrum, which is one of the methods used in an Agile environment. Agile models are typically iterative and incremental. The basic idea here is to develop a system through repeated cycles, that's iterative, and in smaller portions at a time, that's incremental, allowing the developers to take advantage of what was learned during the development of earlier parts or versions of the system. Learning comes from both the development and use of the system, where possible key steps in the process start with a simple implementation of a subset of the software requirements and iteratively enhance the evolving versions until the full system is implemented. At each iteration, design modifications are made and new functional capabilities are added. Again, this is the adaptive nature of the Agile model. What I have seen most in organizations is a mixture of the two models, of predictive and adaptive, into a hybrid model. Here, parts of the project are managed as waterfall, especially when it comes to the early nailing down of scope or to the closing phase. But the actual production, the SDLC, from the design phase onward, is often developed and delivered iteratively in order to develop and test a product in small increments and make last-time changes and big fixes easier. This often leads to interesting vocabulary issues, especially around the requirements or backlog. This is why it's important to know both kinds of terminology. So what exactly is Agile? To use the definition from the PMBOK, Agile is an iterative, team-based approach to development which emphasizes the rapid delivery of an application in complete functional components. The Agile lifecycle starts with a product vision. This vision is generated by the product owner, whose role is a mixture of the traditional project sponsor and the project manager, in that she's entirely in charge of project scope. The product owner then communicates her vision to the team in user stories. User stories describe the product scope and have a very similar function to requirements in a traditional project lifecycle. These user stories are collected in the product backlog. Each one of them is a little cube here, and then prioritized by the product owner and estimated by the technical team based on technical complexity and work effort. So far, things don't really seem all that different from traditional activity duration estimates, right? But then the magic happens. Then the team, in collaboration with the product owner, determines, based on the priority and their estimates, how many of these user stories can be developed in a 2 to 4 week sprint and deliver a workable product. These selected user stories then go into the sprint backlog. And then, every morning, the development team meets in front of a whiteboard in a 15-minute stand-up meeting, in which each member answers 3 questions. What did you do yesterday? What are you going to do today? What help do you need to get your work done successfully? After this Scrum meeting, the developers decide themselves what work they're going to do for the next 24 hours so that they can come back in the next day and report progress. At the end of the sprint, which is the time box of 2 to 4 weeks, how long it exactly is what the product owner determines at the start of the project, the expectation is that the team will deliver a working, tested, shippable product. They demonstrate this product to the product owner in a meeting called the sprint review. In the sprint retrospective, which comes as soon as the sprint review is over and hopefully the product is approved, the team evaluates their progress and the effectiveness with which they have completed their work in this sprint. Now let's talk about Agile in a little more detail. Here's the cycle of one sprint. Keep in mind that based on the product owner's direction, sprints in your project can be 2 weeks up to 4 weeks long. The fun thing here is that we are starting with project initiation and requirements definition and high-level requirements, which really isn't all that different from waterfall. But then we start with our development and integrate and test as we work off the parts of the requirements in the backlog that we have committed to for this sprint. And as we prepare for this development with the user stories that come in our sprint backlog, we develop the test plan. In fact, we develop the test plan first before we even start developing the code. That way, we have a much better idea as to how we need to write the code, here called development 1 through development n, to pass the tests. So then, our first increment is done after 2 weeks, followed by the sprint review, in which we demonstrate what we have built, and the sprint retrospective, in which we discuss how well and how fast we have built our product and what went well and what didn't. But let's go back to the sprint review, that big demo meeting, in which our system has to work. You will be in the room with not just the team, but also the product owner, other stakeholders from the client office, some of their users, and possibly even your boss. And at the end of this sprint review meeting stands the big question. Will the product owner accept the output of your work and you can release your product? Or will she send you back into your lab for rework and bug fixes? Any of this rework, which you're seeing on the bottom blue part of the arrow here, will have to become part of the next sprint. Obviously, if you have any rework and fixes to take care of, that limits the amount of new user stories that you can take on for the next sprint, even if the product owner insists that the normal number of stories will have to be built. Just like in a waterfall situation, the relationship between scope and time is real. And if you have enough budget, you might be able to add more people to the team to get the next sprint done without any problems. Or you might have to add 1 or 2 more sprints on to what you thought was the end of the project. But then it's also important to ensure that you keep track of the money. And when the money is used up and there are still user stories left in the backlog, that's not a good thing either. So, as you may have already guessed from this, Agile is not a free-for-all. And it certainly does not require less documentation and tracking. If anything, it requires intense attention to detail of both the product owner, who makes all the major decisions, and the Scrum Master, who ensures that the technical team has everything they need in order to be successful, and who gets to do all the tracking and reporting for the sprint reviews. As you have just learned, the entire Agile process starts with scope identification. Here, that means imagining how the end user would use your product. Quite often, this is where end users get to weigh in significantly through feature surveys, workflow observations, basically anything that helps the product owner envision what the product should be like so that it generates the biggest measurable organizational value. All the ways in which the system is being used are then captured in user stories. Writing user stories is hard. They have to be short, typically no longer than 1 sentence, so they can fit on a sticky note or a flashcard. They have to be written in the language of the end user, not the engineer or developer, to ensure that the words used show exactly what the user wants and how and why they want it. Once they're done, these user stories are collected and indexed in the product backlog. Each one represents, so to say, a part of a conceptual model. The technical team then takes the user stories, that's the conceptual model, and uses them as the basis for greater elaboration into a technically more detailed design that can be built by an engineer or developer. To make the handoff between the product owner and the technical team easier, user stories have a specific format. It typically goes like this: as a, and then insert the end user's role or job title, I want, and then describe the action that they want to take, and then so that, to give the reason why they need to take this action. This very specific grammar allows technical personnel to easily write test plans for a particular role and focus on the feature that needs to be tested, and on the larger technical integration or workflow context. Here are a few examples. See how they follow this format? In the first example, the role is the user, so that story goes into the test plan for the user role. In the second story, the role is the administrator, so that test plan goes into the administrator role. In the user role test plan, we then write exact test steps for photo uploads. We also connect this story with another story that seems hidden in it, namely a photo sharing feature. That photo sharing feature will need its own story, of course, and will need to be connected to the upload screen in some way. The administrator story also contains a hidden story that may need even further elaboration. In other words, we need to ask questions about the word appropriate. Does the user want just an appropriate-inappropriate switch? Or age range levels, for example, appropriate for adults, inappropriate for children, appropriate for upper level management, not appropriate for individual contributors, that kind of thing? Or perhaps appropriate only for certain roles that exist in the organization's directory server? In other words, the last "so that" phrase can really be nothing or mushroom into a really big work effort. These questions of scope need to be clarified between the team and the product owner and the business level at the latest in the sprint planning meeting. As you may have noticed, test planning here functions as an important step too, if not as a replacement for product detail design. As developers write the test steps, they need to understand each keystroke and mouse click that the end user wants to make or not to make as they execute the user story. This is where a lot of technical detail planning for each test case and test step comes in. This detail planning helps developers write the code or engineers build the networks or hardware that is needed without having to ask too many questions. So precision and a great working relationship with the product owner, who will most likely be sitting in the same office with the developers or engineers, is absolutely critical. Remember that Agile development is all about developing small increments really fast in a really collaborative manner with quick question and answer turnarounds to minimize any waste of time. Here is an example of a user story from a hotel reservation website with the test steps that show how many features are hiding under the sentence in the blue box. Please pause the video and read through these. Then think about all the technical steps it will take to build the functionality that will be tested at the end of the 2-week time box. Then come back. Do you see how there are more technical questions hiding under the details? How, for example, are we going to determine the timestamp when the reservation was made so that a premium member can cancel without a fee? Where are we getting the member's status as premium or not premium from? And what about the second to last one? How are we going to notify the hotel? By email, database notification, text message, automated phone call? As you can see, answering all of these questions and doing so quickly requires immediate access to the product owner so that developers lose absolutely no time. Because remember, the time box is set. Developers must demonstrate a shippable product that can be released at the end of that time box in the sprint review meeting. That can quickly get very stressful. As we said before, the product owner stores user stories in the product backlog. The nature of this backlog depends on the product and on the organization. Sometimes you will find just the user stories with their index numbers, as in the example to the right. Sometimes you might already find some very technical requirements. That is especially true if you're working in a hybrid waterfall agile environment in which the scope has already been more clearly defined in a scope statement or use cases during the initiation phase. Look at the rightmost column in the example. This is where you see the priority column. Here the product owner assigns priority numbers to the user stories and their implicitly connected features that she wants the team to build first. As you see here, the database of the user stories is in fact sorted by the product owner's priorities. Then there's another really important column, perhaps the most important column for all the technical people on the team who are going to build the product, the estimation column. As you can see, this column contains numbers. These are called story points. Story points are estimates of effort. They depend on the amount of work required to build the user story, the complexity of the work, meaning how hard it is to build, and the risk and uncertainty, especially if this is something the team has never built before. Story points are a unit of measure for expressing an estimate of the overall effort that will be required to fully implement a product backlog item or any other piece of work. When we estimate with story points, we assign a point value to each item. The raw values we assign are unimportant. What matters are the relative values. A story that is assigned a 2 should be twice as much as a story that is assigned a 1. It should also be 2/3 of a story that is estimated as 3 story points. Instead of assigning 1, 2, and 3, a team could instead assign 100, 200, or 300, or 1 million, 2 million, and 3 million. It doesn't matter. It's the ratios that matter, not the actual numbers. Because story points represent the effort to develop a story, a team's estimate must include everything that can affect the effort. That could include the amount of work to do, the complexity of the work, and any risk or uncertainty in doing the work. Certainly, if there is more to do of something, the estimate of effort should be larger. Consider the case of developing 2 web pages. The first page has only 1 field and a label asking to enter a name. The second page has 100 fields to also simply be filled with a bit of text. The second page is no more complex. There are no interactions among the fields, and each is nothing more than a bit of text. There is no additional risk in the second page. The only difference between these 2 pages is that there is more to do on the second page. The second page should be given more story points. It probably doesn't get 100 times more points, even though there are 100 times as many fields. There are, after all, economies of scale. And maybe making the second page is only 2 or 3 or 10 times as much effort as the first page. But what if the second page contains not just simple text fields, but some date fields with calendar widgets that pop up? Some formatted text fields like phone numbers or social security numbers, and perhaps other fields that do checksum validations as with credit card numbers. This would mean that the page also requires interactions between fields. If the user enters a Visa card, a 3-digit CVV field is shown, but if the user enters an American Express card, a 4-digit CVV field is shown. Even though there are still 100 fields on this screen, these fields are much harder to implement. They're more complex. They'll take more time. So the effort just got much bigger. Lastly, the risk is bigger too. There's more chance the developer makes a mistake and has to back up and correct it. So there will be more story points because of that. Additional risk often also comes from lack of clarity. If a team is asked to estimate a product backlog item and the stakeholder asking for it is unclear about what will be needed, that uncertainty should be reflected in the estimate. Or if implementing a feature involves changing a particular piece of old brittle code that has no automated tests in place. All of these risks should also be reflected in the estimate. Now that we know the story points, the backlog and sprint planning meeting is next on the agenda. This is a collaborative effort involving the Scrum Master, who facilitates the meeting and is in charge of all the reporting and makes sure everybody follows the process, the product owner, who clarifies the details of the product backlog items and their acceptance criteria and is in charge of all major decisions, and the Agile team, who define the work and effort necessary to meet their sprint commitment. This meeting lasts roughly 1 hour for every week of a sprint. Sometimes 2 or 3 sprints will be planned ahead, sometimes all and sometimes only 1. That depends on the risk of the project and definitely on any schedule and budget constraints. I have often seen budget constraints that determine the number of available sprints, so that story points need to be distributed wisely to minimize the risk of bugs and rework and to maximize the size of the release at the end of each sprint. This is why it is important that the entire team agrees to completing the set of product backlog items that are being assigned to each sprint. Because this agreement defines the sprint backlog and is based on the team's velocity or its work output capacity and the length of the sprint. All of these define the sprint forecast, which is the major measurement based on which the quality of the team's work will be evaluated. Here is an overview of the entire sprint planning process. Please pause the video for a moment to read through all the steps and then come back. Note that the definition of done is incredibly important here. Being done means that the team is aware of what is expected of them to deliver and that they have delivered just that. Done is a means of transparency. It makes sure that the quality of the work fits the purpose of the product and the organization. It's time to talk about one of the most important measurements for work quality in an Agile project. That is velocity. Velocity is the amount of work that a team can complete during a single sprint. Velocity is calculated by taking the sum of all the points for all fully completed user stories in the sprint, not the ones that you have started or that are almost done, just the ones that are completed, tested, and ready for release. The velocity of a sprint, which is essentially the speed and the quality with which the technical staff can get the work done that was planned at the beginning of the sprint, then determines how many story points are being assigned to the next sprint. Velocity is the major metric for sprint forecasting. In the example here, we see a product backlog to the left. From this product backlog, the team pulls the number of story points and obviously the associated user stories into the current sprint that they want to commit to completing. That is the sprint backlog. The number of points is based on the previous sprint's velocity, that is the story points that were successfully completed previously. So in our example, the estimated velocity for the sprint backlog is 26 points. Let's hope that the team was correct in estimating what they could get done and did not overpromise. Now let's look at the end of the sprint. Uh-oh. Out of the promised 26 points, the team got only 18 completely done. 3 are in progress, but they don't count, and the 5 that weren't even started certainly don't count. So the actual team velocity has decreased from 26 points to 18 points, and the user stories that were not completed, those 8 points, are carried over into the next sprint, for which the team can now plan only 18 points. This also means that any 8 points that were already planned for the next sprint will be pushed out, unless the team really ramps up and finishes the 18 points early and can make up for the otherwise delayed scope. As you can see, sprint planning based on velocity means the pressure to perform is on. The good part about user stories and sprint planning is that theoretically, each individual on the technical team always knows how what she is building fits into the overall design of the entire product. That is because the entire technical team has visibility into the product backlog and the sprint backlog at all times. Once a team member commits to completing a specific item, they will be reporting on their progress in the daily scrum. The daily scrum is a 15-minute stand-up meeting in which each team member reports on what they have finished the day before, what they're working on the current day, and if any help is needed, what the help is that they need. This reporting is absolutely critical to making Scrum work. It keeps technical people productive and accountable. Because honestly, who likes to freely admit that they're running into problems they can't solve? Now let's take a closer look at velocity. To calculate velocity, we need 2 components. First, the story points in the product backlog, which can be assigned by all engineers in a blind vote, that's the ideal scenario, or which can be estimated using all the other methods that we have learned before, such as parametric, heuristic, with the Delphi method, and so on. Second, we need the number of story points that was completed based on the agreed definition of done in the previous sprint. That is the velocity of the previous sprint. Now, if there is no previous sprint, meaning that you are in the first sprint, you will want to plan the number of points for that sprint based on the available time you have. Take a look at this example. Let's say you have 6 programmers and each sprint is 2 weeks, that is 10 work days long. This means that you have 10 times 6, so a total of 60 programmer days available for this sprint. In this situation, a good start would be to plan 1/3 of 60, so 20 days, ideally, worth of work in this iteration. Why only 1/3? Because you want to include enough of a buffer to account for standard project overhead, such as setting up hardware and software, team introductions and self-management, and also estimation inaccuracy. Remember that engineers often underestimate how long a task will take. So now we need to talk about the uncomfortable part of Agile management, the frequent, obvious tracking of team productivity at the end of each sprint in the sprint review meeting. But it can get as granular as productivity tracking at the beginning of each day, at the end of the Scrum meeting. In any of these cases, the product owner will want to know how the planned productivity for each sprint relates to the actual productivity, that is, the planned or forecasted velocity versus the actual velocity. Or in other words, she will want to know how many story points were done in each iteration or also each day. And remember that done means fully completed and tested user stories. How many story points were done cumulatively in all iterations since the start of the project? And how many story points are still remaining, either in the sprint backlog or in the overall product backlog? This tracking happens with the help of two main charts. The first one is called the burndown chart. In the burndown chart for a sprint, we plot the assigned story points for the sprint in a linear fashion. That is the red broken line here. And each day, we plot the remaining story points against that line. These are the green dots on the green line. The completed points are the difference between the previous and the current green dot, and the slope gives us the trend, indicating whether we will be able to meet our commitments for the sprint or not. The second chart we find in all Agile projects is the velocity history chart. Here, the team velocity for each sprint will be plotted, where the horizontal x-axis is usually the number of the sprint, or sometimes also the project week or month, depending on the organization's reporting structure, and the vertical y-axis is the number of story points. In our example here, you see that team velocity doubles around 91, and we can see that nobody was working well around the holidays because velocity dropped from 225 to about 50 within that 2-week time box. Each product owner's goal is to keep velocity high, which means fast, high-quality productivity, because that keeps the budget down. Studies have also shown, though, that that can lead to early burnout symptoms of technical staff due to the increased pressure to perform. So when should you, as the product owner and project manager, use high-pressure, high-visibility Agile methods to get something built? And when should you use lower visibility, lower pressure waterfall methods? As you can see on this chart, that really depends on the technical degree of uncertainty, here shown on the horizontal x-axis. If everyone knows their job well, and there are no bad surprises hiding anywhere in the design, a linear waterfall approach might work well, especially if all the technical requirements are well defined and not too complicated to build, like a website, for example. But if you aren't quite sure what is technically needed to transform your user stories into a product, or if this task requires skills that nobody in the organization has, or if people on the team cannot agree on a way to build what you need, that makes the problem complex. And the more complex a technical problem gets, the better a gradual, incremental approach will work. For example, when converting the database backend for a bank's account management system from a relational to a non-relational system. This is where Agile models shine, because they reduce especially financial risk. And if you are at the completely exploratory end, which happens often in high-stakes, one-off industries such as aerospace, when you build a satellite that does what no one has done before, you're looking at a high-risk requirements and technical innovation, which means you will use the best parts of each model, predictive and adaptive, in a hybrid format, to figure out how best to control scope and implementation chaos while still being accountable for both schedule and budget. That sector of this diagram is not for the faint of heart. So here's your summary of predictive and adaptive models. Please pause this video and look over these points to remind yourself of all the things you have learned up until now. So here is what you have learned in this module. You have learned the difference between predictive and adaptive project structures and have seen in detail what incremental and iterative Agile project structures look like. We have looked in detail at how user stories are built and how they are administered in a product backlog. You have also learned how the technical team estimates story points and how the product owner calculates the productivity metrics by which you and your team will be measured at the end of each sprint, if not at the end of each day. And you have learned that if you are in the Scrum Master role, you will be presenting these metrics in the burndown chart and the velocity overview at the important sprint review meetings after your team demonstrates the shippable product that they have just built. Lastly, you have also learned how hybrid project structures are built and in what cases, depending on various degrees of technical and scope certainty, to use Agile, waterfall, and hybrid structures. In other words, you have learned that you can combine elements of each, depending on what the best strategy is to get your project completed as fast as possible with the highest quality and the best budget. This brings us to the end of our module on Agile schedule and budget management. Please take a look at the vocabulary list here and make sure you can define and explain each of these words. Thank you, and I look forward to seeing you in one of the next modules.